The Toshiba OCZ VX500 SSDs offer a quick and simple way to upgrade your PC's performance. Prioritizing storage endurance, the MLC NAND flash-based VX500 series is suitable for users seeking well-balanced speed and features. The VX500 is backed by a 5-year warranty and comes in a variety of storage capacities.
Excellent!
What's up guys, welcome back to Paul's Hardware. Today's video is hopefully going to answer the question, can a 65 watt TDP, 8-core, 16-thread Ryzen 7 1700 CPU be cooled with this fanless CPU cooler right here? This is the no-fan CR95C fanless cooler. It's rated for CPUs up to 95 watts. Cost me 130 bucks on Amazon and it shipped to me directly from South Korea. It is also absolutely huge, so it's not going to fit in most cases, and it's pretty much always going to block at least the top PCIe slot on your motherboard, if not the top 1 to 2 slots. So will it work? Let's get right into the test setup that I have prepared. First off, I'm going to be comparing the CR95C's performance to a relatively comparable in price cooler, the Corsair H100 IV2, which costs $110. That's a 240 millimeter all-in-one liquid cooler. So the trade-off is going to be better cooling with that device versus you are going to get added sound from both the pump as well as the fans on there. Now, both of these coolers ship with AM3 mounts. The H100 IV2, of course, will ship with an AM4 mount now, but this one, the CR95C, only ships with an AM3 mount. It has not been updated. So, for that purpose, I had to use one of these Asus motherboards. The Crosshair 6 Hero is what I'm testing with because it includes both AM4 and AM3 mounting holes that pass through the back of the motherboard. And I did actually also have to scrounge up an AM3 backplate to mount this cooler properly with. Other than that, I'm using an Asus Strix 1080 Ti graphics card, G.Skill Flare X 2x8GB DDR4 memory kit at 3200 at least for the initial testing, Patriot Hellfire 480GB NVMe SSD, Lian Li PCT60 Open Air Test Bench that you can see right here, and the Corsair HX1000i power supply. Now, although the Ryzen 7 1700 has a 65 watt TDP, it is still an 8-core 16-thread CPU like the 1700X and 1800X. The 1700X and 1800X run at higher frequencies, so the TDP or thermal design power is rated at a higher wattage, which is basically the amount of heat that the cooler needs to be able to absorb and dissipate. 95 watts for those higher end ones. Since the 1700 only runs at 3.0 gigahertz base frequency, 3.7 gigahertz turbo, and in my testing was running at 3.2 gigahertz when it was under load across all cores, it shouldn't get quite as hot as the 1700X and 1800X, therefore you have a lower TDP at 65 watts. Now this cooler could theoretically be paired up with a 1700X or 1800X, although I didn't quite go that far. My aim was to get something that was powerful, but not quite pushing the limit as far as what temperature it was going to be running at 24/7, because my ultimate goal is to put this cooler in my home theater PC, my ultimate home theater PC that I've been building, which is supposed to be able to not just do HTPC tasks, but also video recording, as well as playing video games at high resolutions, 4K, and doing VR. Now for my testing, my ambient temperature was at about 80 degrees Fahrenheit. At least that's what I had my air conditioner thermostat set to. That's about 27 degrees Celsius, and that did vary by a couple degrees, but that's my best bet at keeping things somewhat scientific here. Now for the tests I'm going to be running, of course I did an idle test, which is just to boot up, let the system go through startup procedures, wait about 15 minutes, and then take idle temperatures. Then I did IDA64 as my CPU stress test, and that's not quite as intensive when it comes to the max temperature it will output when you compare it to something like Prime 95, but it is well beyond anything I will actually do with this system, especially in an HTPC environment. Of course, let that run for 15 minutes as well, and then took the temperature reading. And then 3D Mark Firestrike, just to give myself something that would test a variety of different configurations. It has a CPU-centric test, it has gaming tests. The scores for that test shouldn't change, but I again took the max temperature reading during it. And then GTA 5. I just did standard gameplay for 15 minutes to simulate me playing a game on this system and how hot it would get. So let's jump right into the testing. The baseline was my, again, Corsair H100 IV2 with the Ryzen 7 1700. Idle temperature was 32 degrees Celsius, pretty standard for my ambient. The IDA64 CPU stress test only got the CPU up to 47 degrees Celsius, a testament to the H100 IV2's cooling prowess. 3D Mark Firestrike gave me a couple scores. The CPU score, aka the physics score, was 16,596, and the overall score was 6,925. Again, pretty typical for a 1080 Ti in this environment. The max temperature while running 3D Mark Firestrike was 51 degrees Celsius, so actually a little bit hotter than the CPU stress test with IDA 64. I think this was a result of specific cores getting hotter, because when it's not using all the cores, it will run specific single cores up to, I saw 3.75 gigahertz when it comes to the max core frequency. Then I played GTA 5 for about 15 minutes. That only got the CPU up to 48 degrees Celsius. Now, when I was running across all cores with it under full load, it was running at 3.2 gigahertz across all cores, and the max temperature probably would have increased a couple degrees if I had let that IDA 64 stress test run a little bit longer. I let it run about 35 minutes, which isn't quite enough to saturate a full-size 240 millimeter all-in-one liquid cooler. But there it is. Again, that was just kind of more a baseline for comparison. Next up, I swapped out the H100 IV2 and I installed the NoFan CR95C. Along with the cooler itself, you get a mounting kit with hardware for AMD platforms up to AM3 Plus and Intel platforms up to LGA 1150, which would also work with LGA 1151. The documentation was pretty clear and concise, and they did include an extra set of spacers specifically for AM3 mounts, and then I actually also had to go and scrounge up the AM3 mounting kit from my 990FX board that I got that AM3 mount from as well. But fortunately, once those brackets are installed on the back and all the posts are installed on the top, it's pretty easy just to drop the cooler straight down on top of it. The screws go in through the top, they are spring loaded to apply some pressure there, and it all came together pretty easily, except for my clearance issues. I encountered two different clearance issues. One was with the plastic shroud that's on the Crosshair 6 Hero. It conflicted with that, so I had to remove it. I might just shave off some of the plastic when it comes to implementing this with my home theater PC, but for now, this was able to get things up and running. Also the memory. The G-Skill FlareX kit was just a bit too tall, conflicted with this, so I swapped it out for a Corsair LPX kit, which is lower profile. This kit is only running at, it's only rated for 3000 speed though, so I was running it at 2933 with the timings that were installed there. So bear in mind with these next sets of tests, I was running slightly slower memory. But with everything installed, I was able to load up, wait for things to cool down, and idle temperature was only at 37 degrees Celsius, just 5 degrees warmer than the idle load with the Corsair H100 IV2. Then I loaded up the IDA 64 CPU stress test. That got things a little bit warmer, but still not too terrible at all. 77 to 78 degrees Celsius was the max temperature I saw there. And in case you're wondering, at stock settings, the 1700 is running at about 1.177 volts under load across all of the CPU cores. Next up was 3D Mark Firestrike. CPU score here was 16,793. Overall score was 7,077. So even though I was running a slightly slower memory and the cooler was making things run a little bit warmer when it comes to the CPU, I still got a higher score, but it's just within the margin of variance for testing something like 3D Mark multiple times. Anyway, though, the max temperature was 66 degrees Celsius, so again, a bit warmer than the H100 IV2, but still very reasonable, especially if you compare it to something like a decent Wraith stock cooler or something like that. Finally, GTA 5 gameplay for about 15 minutes again, and only saw temperatures at about 65 degrees Celsius on the CPU, perfectly adequate for typical gameplay experience. Now, with the NoFan CR95C, I had an idea. Well, first off, I'm probably not going to be using the Ryzen 7 1700. I'm probably going to be using a Ryzen 5 1600X. But you should be able to undervolt these CPUs, so that's what I did next. When you run a CPU at a lower voltage than what it's set to, there's basically nothing that can go wrong. That's not the way I should phrase this. It's basically a win-win scenario as long as you don't experience instability. So just like with overclocking, you gotta test some stuff out, you gotta start to tweak the voltage and bring it down a little bit, but just like with overclocking, you can eventually experience system instability. I was able to dial in a negative CPU voltage offset of minus 0.0875, and that actually ended up in the CPU load voltage being around 1.068 volts, which is pretty much what I told it to do. I am focusing on the voltage here while all of the cores are under load. Do note that if you are testing this yourself, if you are only doing something that's going to use 1 or 2 cores, that turbo boost will take effect with these Ryzen processors, and you can see quick voltage spikes in the 1.4 volts or above range, but As long as when you have everything under load, you're seeing those more nominal numbers in the 1.15 to 1.2 range, that's usually more like what you would expect. Anyway, though, I did run some quick tests after undervolting. The idle temperature dropped by just 2 degrees Celsius. 35 degrees was what it was at. IDA64 CPU stress test, 66C average during those tests, and it peaked at 72 degrees Celsius and then dropped back down. So about 5 to 10 degrees cooler than without that under voltage applied. And then 3D Mark Firestrike did get a bit lower score, but still not terrible when it comes to the variance that comes from test to run to test run. CPU score was 16,377. Overall score was 6,879, and my max temperature there was only 62 degrees Celsius. So all in all, I am pretty damn impressed with the CR95C's performance, and I'm pretty damn impressed also with Ryzen. You know, it's not often talked about the efficiency of Ryzen, but the fact that it's only a 95 watt CPU, if you're looking at an 1800X or 1700X, drops to 65 watts with the 1700 or anything below that. So even in my worst case scenario testing, which was stock settings and IDA64 stress tests, we only peaked at 78 degrees Celsius, and that's still a good 15 degrees C or more from the 1700's thermal limit of 95 degrees Celsius. You could even potentially overclock this CPU just a little bit, although I didn't explore that because once you start adding voltage and adding frequency, especially across all the cores, temperatures start to ramp up pretty quickly. So I'm super happy with the potential for this system in an HTPC and a gaming environment. Of course, it did not come without its drawbacks. Compatibility when it comes to the socket you choose, compatibility when it comes to PCI Express expansion slots. I don't think I mentioned very specifically, but not only was my top by 1 PCIe slot blocked, but also the top or the second slot, which is the full length by 16 slot that the graphics card usually goes in, was also blocked. So when I installed the CR95C, I had to move the GPU down to the secondary SLI position for that, but even though it's a by 8 connection, it's still been performing just fine, and I didn't really see much performance degradation, at least when it comes to my game testing. But guys, that is all for this video. I really hope you've enjoyed it. I certainly have had a good time over the past 24 hours or so, giving this a bit of a test, and I think there's a lot of potential out there, not just for this CPU cooler, because this one's a little bit harder to find. There's also a full copper version of the CPU cooler. It's even more hard to find, but I'd like to see more fanless CPU coolers available. I feel like they kind of come and go pretty quickly, and there's not a whole lot of them out there and available. I digress though, as Jay might say. Thanks again for watching this video, guys. Hit the thumbs up button on your way out if you enjoyed it. Leave me some comments in the comment section down below. I have more work on Arctic Panther, as well as my HTPC, as well as typical video content coming to you very soon, and we'll see you guys in the next video.